So I'm going to talk about TypeScript, which is a language from Microsoft for generating JavaScript. As you can see, I'm using a Mac here, and in fact, my entire stack is on Microsoft except for their compiler. So we'll get to that. I'm kind of new here, so just a show of hands, how many of you use Node pretty much every day versus, learning and tinkering? So we've got just a couple.
I use it for Chrome, so certainly.
Okay. And pretty much all of you are familiar with JavaScript. Model view controller, that's no problem for, I'm seeing a lot of heads nodding and a few. All right, so that gives me some sense of where I am. So I'm going to spend about half the talk or so talking about why you might want to choose TypeScript and half on how to use it. And really, I think the more important question is why. How would you choose a language, and what might cause me, who has managed to avoid using Windows for pretty much my entire professional career, to actually use something like this. So, just a little bit about me so that you have some sense of where I'm coming from. I work for a tiny company called Vocalabs. We do customer service surveys, and I've been pretty much the lone developer there. It's a tiny company, and so I do the QA, I do the front-end code, I do the back-end code, and that suits me really well because I love, hardcore algorithms, but I also like the psychology of user interface design. And so I get to see all of it, and it keeps me honest because every single stack trace ends up in my inbox. So before that, I got my master's degree at the University of Minnesota working on the Group Lens project, which was personalization, what we would, rate things 1 through 5 stars. Amazon started doing that. They commercialized it as Net Perceptions, and I went there eventually after a hiatus at Gauge Marketing Group, which I went to for a reason that recruiters will tell you never to do, which is they were using Next Step. And I wanted to learn Next Step before Next went out of business. So it turned out really well for me. Not just because Apple ended up absorbing Next, but also because a lot of the technologies have reemerged in various places. So another way of looking at my background is in lines of code. At Vocalabs, we don't use a whole lot of JavaScript. We use extremely little Node. But, since 2002, I've built up a huge amount of Java, and I'm slowly replacing that with Scala, which is my current favorite language. And then we've got about equal parts TypeScript, JavaScript, and so on for literary languages. So, my philosophy is, so I see code as a form of technical writing, and I have a very specific target audience. And the person who I am targeting is honestly kind of an idiot. He doesn't read any of my documentation. He doesn't have time for architecture diagrams. He just grabs a stack trace and dives into a line of code and expects to understand it with no context. And he doesn't have a whole lot of patience. So that's who I'm writing for, and that's kind of what drives everything else that I do in terms of how I program. So, like I said, I do everything from the frontest front end to the backest back end. And I found that in doing this, there are two kinds of programming. And a lot of developers just end up doing one kind or the other for sometimes their entire careers. And so they think that the other kind of developer is crazy, stupid, naive, what have you. And I think what kind of developer or what kind of programming you're doing can be boiled down to one question. And that is, how do you know that your code is correct? So for some people, they would say it's correct if it conforms to a specification. And by specification, it doesn't have to be some formal written document, but it can be just a clear, well-defined expectation of the code's behavior. Whereas other developers, typically front-end developers, forget any specification. We don't have time for specifications, and the specification's wrong anyway. It needs to work in the real world. And so that encourages more rapid experimentation. So I'm going to give you an example of this in one line of code. This is kind of a Rorschach test to see what kind of programming you're used to. We're going to see if this works here. So, if you are a one kind of developer, the one who likes clear, well-defined code, then you would look at the exception and say, there's an implied contract here. You know, here's a testable assumption. Whereas if you're the other kind of developer, you look over here and you say, that looks like some text that the user is going to see. How do we know the user's not going to look at that and panic? How do we know the user's going to understand it? How do we know the user's not going to see it at all and ignore it? And so one line of code, kind of, that's the range of different possibilities. So if you emphasize design clarity, kind of an extreme example of when that's most appropriate is implantable medical devices. I don't want anyone putting anything into my heart unless everyone knows exactly what it's supposed to do. And then there are external APIs, you know, Angular, what have you, Node's API, where jQuery I've been fighting with a lot lately. But jQuery is an example where, right or wrong, it ought to do the same thing. Or CSS, I've been fighting with that a lot lately. You know, I don't care what the right answer is, but I would sure like it if all the different web browsers agreed on what it does. So design clarity is important there. And also I want to emphasize internal APIs. The APIs you write for yourself also fall into this category. Whereas on the other side, you've got user interfaces. Are there UI, UX people here? Okay, we've got some of them. So this gets into psychology, this gets into human factors, and you literally, you cannot know if your code is actually going to work, no matter what the specification says, if you haven't actually tested it on real users, and not just any real users, but real users like your actual users under same psychological circumstances. Another example I really like is business process and workflow. This is where Agile comes out of, and I've been seeing online a whole lot of flame wars lately about Agile versus other models, and you know, workflow is, and business processes, you know, internal IT stuff, that's actually even tougher than user interfaces, because that's not just psychology, that's sociology. Now, one example from Vocalabs, you know, we do, since we're a business-to-business company, we do a lot of, helping out our customers, and so we have this sort of case that happens from time to time where you've got a manager who spends an hour or two every week writing a report, and then we say, oh, we can generate that for you. Boom, 2 hours of free time for that person. How does it get filled up? Nobody knows. If you're doing a long kind of process with clear, well-defined specifications, then by the time you write this, you're basically guessing. Nobody knows how it's going to change specific employees' workflow, their relationship between each other, the relationship departments when you actually go to deploy. So in business processes, you really need an agile, very fast-paced, back and forth, try something out, see if it works, see how it changes. And I'm not even getting into the politics of someone wants this particular feature because it's a safety blanket and they won't actually ever use it. And finally, this sort of rapid experimentation is not limited to psychology, sociology, high-frequency trading. That's on Wall Street when they write computer programs to trade stocks and bonds. And there, you're in a situation where it doesn't matter what the specification says. What matters is, you put it out there, and then someone else's AI second guesses you, and you've just lost $5 million. Versus you try something, it's buggy, but hey, that bug actually helps you because it saves a few milliseconds. You just made $5 million. So I'm not going to say a whole lot about this, but testing, code reviews, that's for design clarity. Rapid experimentation implies usability tests, iterative design, agile methodologies. One thing they all have in common is that they both require flexible, easy-to-read code so that you can maintain it, and importantly, so that you can change it as requirements change. So, now we get to TypeScript. So, working on a particular project that I had at Vocalabs, and this was a animation, a very complicated animation. I've been using JavaScript for years, but mostly pretty light stuff, sometimes getting very deep into it, but I had something where it's 1,000 lines of code practically, and it's all tangled with all sorts of nested this, that, and the other thing depends on this other thing. And I was banging my head against the wall trying to get it to work. And I'd also discovered, having had an intern working with me briefly, I thought, oh, JavaScript, that's an easy language. We'll just ignore these, this huge Java code base. We'll do a little project in JavaScript. That's easy. And I thought, okay, object model. JavaScript doesn't really have a good object model. You read a book like JavaScript, the good stuff, and it doesn't give you one object model. It gives you 3 different. Pick and choose your favorite. It's turns out not to be a perfect language. So anyway, JavaScript though is good for rapid experimentation. You've got a console in your web browser where you can play around with a whole lot of stuff. Great tools, but a little trickier when it comes to design clarity. I also looked at JavaScript compilers. GWT is one that compiles Java into JavaScript. And what it produces is completely unreadable. it kind of forces you into their own world where you can't use you can't use jQuery, or you can't use the latest thing with it. TypeScript appealed to me because, for one thing, I'll get to this a little bit later, but it's a lot easier to mix and match and work within a JavaScript environment. So another way to look at this design clarity and this rapid experimentation dichotomy here is through the lens of model view controller. And having done Next stuff, which is very similar to Apple programming, they strictly enforce you've got separation between model, view, and controller. And I believe that pretty much every program has a view, a controller, and a model, but most of the time they're not very well separated. So every MVC framework defines model, view, and controller slightly differently, but for our purposes, the controller is what makes your program unique. The model, that's the well-defined, testable, reusable code. So the controller would not contain a whole lot of reusable code because, if it's reusable, it's not unique. And, if you start repeating yourself, maybe that belongs in the model. So, and this is probably the most important thing that I'm going to say tonight. If you don't remember anything about TypeScript, I want you to remember this. Good programming is not about, having a well-defined model and well-defined specification, at least initially. It's not about rapid experimentation and the ability to do that. What makes code work over time, and I've discovered this both positive and negative, having worked at Vocalabs on my own code for so long, it is your ability to do your rapid experimentation and then drain it as quickly as possible into the model. And so languages and tools that facilitate that are far more useful than something that's just good at agile development or just good at maintainables code or coding to specifications. And the other point is, once your code hits a certain level of complexity, increased formality saves time. In my case, with the project I was working on, it took me 1 day to convert from JavaScript to TypeScript, and it paid off within a day. As in, converting it from JavaScript to TypeScript was basically a very in-depth code review with the computer helping me out to test my assertions, and I was immediately finding tricky bugs that would have taken at least a day to discover, figure out where they were coming from, and fix. So that's why TypeScript, so that you have fewer bugs and better tools, and with a minimum of fuss, you can work with JavaScript if you want and formalize as you go along. Any questions, comments, arguments? Okay. I was expecting with the beer this would be a much louder audience. Okay, so TypeScript. You've got a compiler, TSC, which is a Node application, so it runs on everything identically. Like I said, I run it on Mac. and I pretty much have no Microsoft software except for this TypeScript compiler. And the runtime is pure JavaScript. You can compile to ECMAScript 3 or 5. ECMAScript 3 gives you IE6 capability, and 5 is for more modern versions of JavaScript. And for IDEs, Microsoft would like you to use Visual Studio. That requires Windows. I understand it's free if you have Windows, but that's kind of expensive for me. WebStorm, which is what I use, runs on just about everything. It's also a fantastic IDE if you're just doing JavaScript. And if you don't want a full-blown IDE, you can use Sublime, Vim, Emacs. There are plugins for the grammar. So, TypeScript itself. They say it starts with JavaScript. You add optionally static types, classes, and modules, as well as a few ECMAScript 6 features. And then it ends with JavaScript. That is to say, it compiles back to not just any JavaScript, but idiomatic JavaScript. So for me, starting on this year and a half ago, when they were at version 0.8, and I was extremely skeptical of it, it's like, okay, I generate this JavaScript from this TypeScript. I'm storing both of them in version control so that if I ever decide I don't like TypeScript, I can go back to JavaScript. It's got all my comments. It's written very similarly to how I would have written it, close enough. So it's a 100% code back guarantee if you want to try it out. And it runs pretty much everywhere. So, that said, I've got a whole bunch of stuff. We can go faster or slower if you guys have opinions. And I'm going to start out. So this is typescriptlang.org/playground if you... Oh, shoot. This is only on my window. Here we go. Drag it over here. I wonder what will happen if I press this. Hey, you did the right thing. Okay, so typescriptlang.org if you want to play along. I'm going to turn on mirroring so I can see what I'm doing. Oh, and now it's... Here we are. So, this is a TypeScript compiler running in the browser. It's actually uses the same code as Microsoft's IDE, so I believe if I command click on things, it'll do all of the code completion and everything like that. But, so what we've got here is we've got a function over here written in TypeScript. You'll notice it looks just like JavaScript because it is. And on the other side, you've got it compiled into JavaScript, and it looks pretty much identical. Let me just prove this to you. So, oh, it even put in the spaces. What the? See, oftentimes it'll compact for you. But. So, we've got a function foo that takes an x, and x is of type any. And any means literally anything. It is your escape to JavaScript. If you're familiar with strongly typed languages like Java, you've got the root object where you can't do anything with it unless it conforms to object. Any is in TypeScript is the exact opposite. So in this case, anyone want to tell me what might be wrong with this code here? Is this going to work the way I expect it to? What's wrong with this code?
The scope, right? I mean, there's no var or whatever the types get.
Oh, shoot. No. Scope's not the issue. I mean, it looks like perfectly decent JavaScript.
Can I assume object plus object? What does that do?
Right, that's the thing. I can't, pluses don't really, you can't do a plus to string. It'll just ignore it. I mean, you can't do .name to string. It'll just ignore it if you try to add stuff to it. And pluses only work with primitives except for string concatenation. So this doesn't actually really work. I mean, you could try doing it, and if you're lucky, then X is a string. So we don't really know what X is supposed to be. But TypeScript will let you get away with it just for the sake of letting you get away with it. But if we tell it X is a string, suddenly it's giving us a compile error. Because string doesn't take hello. So let's get rid of that. And we can cast it to any of the primitives, Boolean, and Booleans don't take plus. Anyone know what happens if you add two Booleans together in JavaScript?
It's false.
Close.
It's true.
True plus true.
It's NA.
True plus true. I tried this out because I was curious. True plus true equals 2.
Of course.
So, TypeScript's not going to let us do that, even though JavaScript does. So, we can do number. So, TypeScript, JavaScript actually has two kinds of numbers. There's 64-bit integers, and then there's 32-bit signed integers, but you have to do bitwise coercion to get to the latter one. They say that it's only doubles, but that there's only 64-bit doubles, but that's not quite true. So we've got the typed number. We can also cast this to an object. So this is an object that has something called A, and not colon, semicolon, and B, which I'll say is an int, or not int, number. Maybe someday they'll have dates. And it's giving me a compile error, but now we can do x dot and A. We've got A or B as our options. So, now if you don't like IDEs, I would argue, based on what I was saying before, TypeScript is still a win for you because it won't let you compile if there's something obviously wrong with your code. If you want to be flexible about it, then you just say that something is an any, and you're back into JavaScript land. we can also do a C question mark. Whoops. And we'll do that as a string. Oh, it's not letting me do that there. I'll do that. Oh, thank you. And let's see if it lets me do that. So, question mark means this may or may not have a C, but if it's got a C, it's got to be a string. So, I'm going to do XA. I'm going to have a return value here of x.b. Oh, that's what I want to do. So now we've got something where it returns something of the same type that was passed in. And it's telling me how I can do this. And now it knows that C is of that particular type. So we've got type inference. So the compiler is coming up with these long chains of inferred types so that you don't have to tell it what kind of types there are. And if you've worked with Java and especially generics in Java, then you know that other languages that don't have type inference, you can have something that's a model. Literally, the reason that I ended up switching to Scala was when I wrote a line of code where it was literally 200 lines long, and it was just, you know, a variable and a declaration. But let's formalize this a little bit. We have interfaces. So, and interfaces, you'll see, they disappear in JavaScript. So, incidentally, this JavaScript here is also valid TypeScript, and it's also running in the IDE, so we can see what types are here. So, interface thing, we'll just copy this. And so C, we didn't say that it's not automatically detecting that the interface matches and saying this is a thing, but we can do that by saying here returns a thing. And now we'll see that C returns a thing, and if we try to modify this somehow and say plus hello, we get an error because it's not a thing. Now these types are very flexible, and interfaces you can, as long as it conforms to this interface, it'll be okay. So we can also add a Z, and that's still a thing. questions, comments? Hmm? Okay.
Yeah, I got one.
Yeah.
So where does it break down? So if you return, if on your interface thing when you're defining that, if A was a number, then
Then it'll say x dot a is a number, and it will not automatically convert numbers to strings the way that JavaScript does. You would have to explicitly convert it. Well, actually, no, you can't. So, going the other way, here again, in JavaScript, you would have b is a number, and so, but it needs a string, and it would automatically convert the string to the number, and you get into really weird situations where, you know, you're expecting 0 the string, and you get 0 the number, or vice versa, and you add 0 to 0, and you end up with O the string. You know, TypeScript will not let you get away with that. But we can do plus double quote, and it's happy. So we already did optional types. My brain's in Scala today. The other thing about TypeScript is that a lot of the effort that Microsoft has put into this is in coming up with interfaces to explain all of the popular JavaScript libraries. And I'll show that later on when I do a little bit of node programming. But as a result, you know, all the squirrely things from the DOM that are possible here. We can have C, which is a function. Oh, thank you. So, a function returns this. So then we need to give it a and then it's happy again. So we can give it a function. We can make sure that the function has arguments. And it'll allow this because, you know, it's okay in JavaScript to have a function that would take arguments, but we're ignoring the arguments. So, but if it does have an argument, it's going to expect it to be a string, a number. So, if it takes an argument, it has to be that argument. Other interesting things. We can also have, we can overload this. C can also be something that takes a string and returns a number. I forgot the semicolon. Why doesn't it like it?
C twice.
Yeah, you can in fact define C twice.
True.
What doesn't it like?
In the function that will pass the object in return, can you define that as a string? Or maybe it's assuming that you haven't defined that it's supposed to be a form for the ladder.
I mean,
You could do it before.
so I'm just going to working for me before. Well, shoot. You know, maybe they changed that at some point. But, oh, I wonder if they changed the grammar. But it is possible to do overloading. And then, because a lot of JavaScript libraries do that sort of thing where, you know, if you pass in a string, you get back a string. If you pass in a number, you get back a number. TypeScript does a certain amount of that. Since it compiles to JavaScript, if you do overloading, then you end up with a situation where you're going to have to write the actual code that implements it at runtime. You know, you're going to have to write that by hand. So if you have a function that takes a string and returns a string, what you really have to do in TypeScript is have it determine what type it is. You know, you write that code and you get it to work. Because there's no good way in JavaScript to detect types. I mean, you can with primitive things like strings and stuff, but when you get to interfaces, then that all breaks down. So, generics. This is another way to get through a similar thing. So we've got a generic type T. And, whoops. So we're going to pass in an array of type T, and T can be anything, and then we're going to return something of the same type. Okay, what am I doing? So, arrays of type T. Function declared non-void type, but it does not have a return. Okay, so the problem is that I haven't finished. There we go. So, we have defined a generic type T. It can be any type. It can be a thing. It can be a string. It can be a whatever. So we have x equals, choose random, and then we're going to give it an array of, right now it's any because we're giving it an empty array, but as soon as we give it a string, then we know that X is going to be a string. If we give it a string and a true, let's see what it finds is that is somehow the most common type. So that's generic. We can also, we could give it things, you know, from our interface, and so on. So next we've got classes, and these are based on the ECMAScript 6 classes. So they're aligned to the upcoming next JavaScript specification, as they were when TypeScript 1.0 came around. So if the ECMA committee changes and ECMAScript 6 ends up being something slightly different, then TypeScript 2.0 will be aligned to that. But 1.0 is permanently aligned to where the draft was earlier this year. So I'm going to define class point, and it has created a point in JavaScript that's a pretty common way of creating classes in JavaScript. So a point has x, y coordinates. I don't have to say bar because it's very similar to how the interface is defined. And because this compiles to JavaScript, the default is to treat these as public. So we say this x equals x, this y equals y, and now we have points. And then let's do a distance function. Return square root of, you have to specify this every time. And when I write my code, I always put in parentheses for the math, because if you're working in multiple languages, you don't want to have to think about whether it does the same thing. That's just a source of bugs. So, distance returns a number. So now we've got a class, and this is very similar to regular object-oriented. We can simplify this, though. Let's get rid of these and these, and we're going to say public x and public y is also a number. And it generates the same JavaScript that we got before, doesn't it? Yes, it does. And in fact, I find that this is my typical constructor that I have in TypeScript, is an empty constructor. that just says, here are the public things that it takes. TypeScript does not allow more than one constructor. And I'm not, they say that that was an intentional language decision. I don't know if that's necessarily the case. The trend in languages these days is to be against multiple constructors nowadays. But if you're coming from something like Java, you probably want to subclass this. Class 3 point. What did it say is wrong?
Need a semicolon at the end of point?
Oh, it's because you can't start with a 3, yes. And if I had looked at the color of that 3, I would have known. Okay, so point 3D. And is it extends? Yes, it extends. And I'm just hesitating because I expect it to, you know, type constructor for me when I start writing constructor. But I guess Microsoft's IDE is a little different from most. So we've got an X, Y, we've got a Z, and we're going to make this one public. And at this point, TypeScript can't continue until it adds a little bit of features to JavaScript. So we've got this extends that it's invented here. And who knows, maybe in the future they'll get rid of it if you compile to ECMAScript 6 when that comes around. But for now, it is generating a little bit of JavaScript as needed. So we need to do distance again. And square root. Actually, so we call supers, and then square root of here we are. How is it doing it? It's got an underscore super, which it is using to store that stuff. Again, it's generating stuff that's maybe not exactly the way you would have written it, but it's close enough. Another cute thing, and I haven't gotten this to work with subclasses, so I'm going to comment this out. But if you are doing this on Angular or modern browsers where you can use ECMAScript 5, then ECMAScript 5 has properties. And you can do that in TypeScript by saying get distance. And here's your get is a function that returns that enumerable yes, configurable true. Unfortunately, a number of our clients insist on using IE7, so I'm stuck in ECMAScript 3 land. So I don't use it. So, what are we doing for time? It's almost 8. We're doing all right. ECMAScript 6 lambda functions or arrow functions. So let's see if I can do a simple one of these. Actually, let's see if I can grab some sample code here. Any questions as I'm going along? I'm about to delete all this. This is, I was going to fix the code. So you've got this on mouse move function. And you've got this in here. And if you've done very much client-side JavaScript, you've probably found that this is half the time not the this that you expected it to be. And so in this case, we've got, in TypeScript, I always define something called self. That's usually the first line of any method is var self equals this. And I've seen in the bug reports that they have for it a lot of feature requests for adding that to the language. And I certainly would be in favor of that. So this dot count would be right now. Let's try running it.
Your code wasn't commented though.
Yeah.
The second code.
Oh,
Yeah, 8.
The bottom. Last line.
there we go. That's better. So, and I believe I am, writing to the console here. And it's not doing the right thing, which is, of course, right because, oh, wait a minute.
You have to refresh the window.
Yeah.
Oh. Window. Have to refresh the window, you say?
Close that one and then refresh the other.
Which what?
Oh. The second tab, and
2.
then open the third tab.
Oh,
So
I
you have to
know.
leave your console open while he's refreshed.
That's the problem, right there. I actually have to use the code. So, now we pull up the console. And it's giving me, you probably can't read it very well, but not a numbers, because we're using the wrong this. So, you can either say self dot instead of this, and that should work. There, now we're actually getting numbers there. we can do lambda functions, which look like this. So, lambda functions, one of the nice things about it, oh, and the parentheses are optional, but I really like to have the parentheses because it tells you that it's actually a function argument here. So this reads as E is the argument for, and actually we're not using E, but we have a function, and that arrow thing means here's the function definition. So you'll see that it just rewrites it as function. So with the lambda, the difference is that this is now the object this, not the this that from the window. And this is a feature of ECMAScript 6. So here we go, and it's actually working properly. So, like I said, I use the lambda functions because, it's easier to write really short things. The real reason for it that you trade one this for another this, I end up, doing self and this anyway. So, next, and kind of the final feature that I want to talk about is modules. There are two kinds of modules in TypeScript. There's external modules, which are exactly the JavaScript modules that you're used to if you do Node. And then there are internal modules, which are TypeScript-specific modules. So, show you what that looks like. We've got util. Oops. So now we have a module, and you'll see that it's creating this function util in the JavaScript. This is pretty much the way that you do it, that other languages that compile to TypeScript do it. I understand it's some kind of a standard way of doing modules. So, module, we can have modules within modules, and now if we want to create one, we say Vocalabs util tracker, and is there any more there?
I'm missing a filter.
Okay, there's an arrow.
Consoles misspelled.
That would do it. Vocalabs.
One more and curve.
Yeah, there's.
Where are we? Oh, of course. No, that's right. There?
You got Vocalabs and.
Oh, yeah, there we go. Now it compiles. Okay. Now what's it complaining about? And with modules, we need to explicitly export them to make them public. And again, that is a TypeScript convention that is not enforced in the JavaScript because JavaScript has no concept of private. So, that's internal modules, as they call it. And now we're going to switch to, this is WebStorm. And let me actually, I'm in presentation mode, so let me just show you what I've got here. If it'll actually display properly, I've got a file. Yeah, you can read that. Node.b.ts. That's a definition file. And what that is defining Node. So everything that's in Node from require on down it's got interfaces for it. And then I'm going to have a simple server, and then I'm going to run it in a separate application. So, make things nice and big here. So to do this, when you're doing this with Node, you need the compiler flag -module common.js. If you do JavaScript modules, you know that there's AMD and there's common.js. You want common.js because that's what Node does. And then I'm just going to uncomment this code that I wrote before. So we've got a so we require HTTP. Let me see if I can pull up the JavaScript that it's generating. And then we have my server that takes a port, which is a number, and a message, which is a string. We're saying create server, which takes a function, and then we're going to write the message and the date. And then we're saying listen on the port that you gave. And then we've got console log so that you know that it's running. One thing down here, I compile with the source mapping. I don't know, how many of you are familiar with the source mapping, the .js.map? This is supported for JavaScript on all of the major web browsers now, where if you have a third-party language and you are compiling to JavaScript, you can have a map that maps to the source code, which means that if you run this in Chrome or Firefox and you pull up Chrome's debugger or Firefox's debugger, it won't take you to the minimized or the original or the JavaScript that you're using. It will take you to the original source file according to what the map file says it is. So if I'm debugging in Chrome and I've got TypeScript, I can see, I can put breakpoints in Chrome in the TypeScript code that Chrome is showing for me. So that's one file here, and then we're going to have a run simple server, and let me pull up the JavaScript that it's generating. this. So, I am importing, so I'm using require here of HTTP because that's a standard Node thing. I'm requiring simple server. I'm not saying .js. TypeScript will figure that out for me. And then SS, and we've got code completion here in WebStorm. My server, and it's telling me that I want a port and 9876 and NodeMN. And do I need to tell it? No. And it compiled properly, and let's see if I can actually get this to work. All right, Node run single server.js. It says it's listening on port 9876. We're going to try 9876. And with luck, Chrome will not try to take me to Google search or whatever. And here we are. A simple web server written with Node in TypeScript. Any questions? So, the source code, if you'll recall, the source code was write a message and the date. And it's not doing any caching.